Hey guys, welcome to the summer's Let's Learn Python project, video number 7. I'm speaking really fast because I just realized that broadcasting from this balcony, I'm getting bitten by mosquitoes, which was a bad life choice. But anyway, I made it, and I can see stars right now, so I guess they're like trade-offs, you know. Anyway, so let's get to it. Today we have a lot to learn, so I'm going to speak real fast, and you might have to watch this again. But hopefully not, because we should be able to get it the first time. We're not going to learn what we promised to learn this week, or this video, because we have an assignment at the end of this video, which is awesome, but it means you need to learn some very specific things for an assignment. So let's get to it. What we're learning today are main function arguments, which are slightly different than the arguments we learned last week, I believe. And we're learning, what else are we learning? File input. File input's important because you want to be able to deal with things outside your code, which, yeah, you don't want to hard code everything. So here we go. Outside inputs, don't worry about what this function does. This function is Euler's differential equation solver, or the first order Taylor approximation. Don't worry about it. For those math people, you should know what it is. For those non-math people, that's okay. But what we're looking at is this right here. This is taking things from outside our function in the system arguments. In fact, it's called arg values, or argv, and putting them into our function. That's wild because we didn't even declare these variables. But when we call the function, which we did, or I will, right here, excuse me, I'm going to delete this. There we go. When we call the function, we declare the variables out here. Or maybe if we're using a script, we'll declare out in that script. That script being in bash, which is this. Anyway, because we declared them out here, we don't need to redeclare them inside our code. In fact, we can have them be flexible and variable. Ha ha ha. But it also means we need a name for them. So this is how you bring things into your code from outside. It uses the system module, so that's import system, sys. Import math is for later down here, it doesn't really matter that much. But our system has our arguments here. So it starts at 1 and not 0. The 0th argument is the name of the function, Euler.py. But the first argument, the first index has 0, the second index has 1, the third index has 10, and the fourth index has 1, just in this case. You can change them around later, and we will. But it stores them as strings, and you're able to take them back, to pull them into your main function, which is awesome. So let's see it happen. Bam. We're pulling these arguments in, we're doing a little math with them, and we're approximating the function. In fact, this is exactly what the grapher does here. It's going to ask for my function, and it's going to approximate it for the entire screen, but it's taking the function -5 to 5, and bam, approximating the function. It just has pretty interfaces. So yeah, that's that. Anyway, you need to press these into the data type you want, because they come as strings. I don't think there's any way to get around that, but it's not too hard. Hopefully your user's smart enough to put in the right type of data. If I put in A here, I don't know what, yeah, it would freak out. Yeah. It allows us to change things around. Suppose I wanted to go from, where is it? Obviously, not my first time around this video. 0 to 5 now, instead of 0 to 1. Because this is our initial t and our ending t. And we wanted 100 steps. That's crazy. Well, let's see it. I changed this 5 just to compare it at the end. So this is e to the 5th, and this is an approximation for e to the 5th using the first order Taylor polynomial. Yeah, cool beans. We just changed the output only by changing our inputs, which is how functions should work. So now we have a full main function. It's like actually a function instead of just some useless, well, not useless, but piece of code that we have to hard code everything into. We can change things around, and I can change it around by taking 1,000 steps, and I'm surprised that ran so fast, because that was a lot of numbers, you see. Yeah. Anyway, good to know. Also, the approximation is a lot better. Wild. That's how system arguments work. You just pull them in by index. Don't forget to press them into whatever you want, or whatever you need. Indexing starts at 1, and uses a subscript operator, which is also known as square brackets. System.argv square brackets. Yeah, that's all I got for arguments. On to our second part. We have I/O stuff, or also known as file input and output. Now, this is sort of related to the last topic, in that you want to be able to use your file inputs and outputs to be variable. You don't really want to define them in the main function. So you want this, where we tell it, oh, I want this function and this function. But those are command line arguments. Those are arguments you're passing into your main function. So it's really nothing new. You can define them here. Instead of sys argument, you could say, oh, well, excuse me, didn't see that happening. Yeah, you could say test.txt, but that's really clumsy, and you'd have to go into the code every time you wanted to change it. So what is actually happening here? We're taking the first argument, test.txt, which is a string, remember they come out of strings, and putting it here. The second argument here, out.txt, and then we're using the function open. So open opens the file for reading. It opens the file name test.txt. Same thing with the output string. It opens out.txt. That's pretty wild if you think about it. We're opening a file in our code, and it returns the file as an object. Isn't that crazy? Like that. This is the file here as a variable. Admittedly, if you do something to it, it won't like delete the file unless you tell it to actually delete it. But yeah, it's a pretty crazy idea, I feel. I don't know. Here we're telling it to read it. Here we're telling it to write it. You actually don't need this. It's implicit that you're reading it, but I'm just going to leave it there because I'm kind of an explicit type of guy. Yeah, so let's see some stuff with it. Before we try this more fancier type, let's just print out whatever is in file in. So we're going to read the entire file. That's read, and then the function handle, the function read for a file, and yeah, let's see what happens. Oh, that's what's in text.txt. This is my file, encode me. Well, encode me, we'll learn why we're saying that in a little bit, but hey, look at that. Exactly it. And we printed it out. However, what if we wanted to print it out to our out file, which is out.txt? Well, I'm going to delete it right here. Yeah. So you can see, oh, that was a cool sound. It produces a new one. You don't have to delete it, it'll just overwrite it. It won't warn you, so just remember that. Yeah. So that's out.txt. And out2.txt, well, we'll get there in a little bit. We actually might not get to the assignment in this video because it's getting long and I'm speaking really fast already, so maybe in a second video, but it'll be up by tomorrow. Yeah. That's pretty much it for opening a file and then reading from it. And also writing to it is the same write function. However, holding a file with the read function, that takes everything into memory. And that sort of thing is really expensive. Well, not expensive, expensive in memory. Because what if this file is like 400 pages long? That's terrible. Your computer will just hate you. And I almost said hella. Yeah, I know. I'm from SoCal. I shouldn't say these things. Anyway, yeah. It'll just hate you. Don't do that. Don't say hella. But don't do this read function. Instead, you could say for line in file in, print out this or write this. And that's kind of tricky, right? Because a line in a file, that looks like the for loop back here. By the way, this main function is an excellent example of everything we've done so far in Python. So if you want to take a gander at it or freeze this video right now, go for it. But if you look at it, yeah, for, but this is for a line in file. That's tricky. I just learned about it a couple minutes ago. So yeah, but you can write it out line by line. Pretty cool, huh? The last thing I have to say about file input and output is you should close them at the end. It's rude not to. It's not a good choice if you don't. I know you can get away with not doing it in other languages. I don't know about Python, but I'm not about to try because it kind of is not good for computer reasons. And by computer reasons, I'm actually saying that I don't really know why. But I know sometimes it'll mess up your computer and it'll mess up your files. So don't do it. It won't mess up your computer permanently, but just don't do it. Yeah, always close your files, please. Yeah, so that's all I have to say about that. This video is already long enough. I'll see you later. Assignment will be posted on Facebook, and maybe I'll make a video about it. Okay, bye.